Welcome back to our AP Chemistry Chapter 7 notes dealing with energy and the first law of thermodynamics. I wish to remind you that previously we looked at finding the change of enthalpy by counting the energy taken in breaking bonds and the energy released in forming bonds. And that is a great way to find a change in enthalpy, and I would be absolutely shocked if you weren't asked to do that somewhere on the test in May, more than likely in the multiple choice section, but could definitely appear in the free response section. But bond by bond is a slow way. It works, and if that's all the information you're given is bond energies, that's certainly the way you're supposed to solve that equation. But to speed things up a little, and I don't want to call this a shortcut because it's not like we're trying to shortcut anything, but certainly it's more convenient for us to not have to go bond by bond. We're going to use this method by which we're going to go compound by compound. So this method is using what's called heats of formation or enthalpies of formation. Why would we call it an enthalpy of formation? This is the heat or enthalpy change, could be positive or negative, could be endothermic or exothermic, to make a compound from its constituent atoms. Now this is done at STP in the standard states. So if I was making, I'm trying to think of something, if I was trying to make, wow, a whole lot of diatomics are involved usually. Okay, so let's say I was going to make methane. The constituent atoms of methane, CH4, would be carbon by itself and hydrogen diatomic because it's in its standard state. All right. If it is elements that are not diatomic, then don't make them diatomic. If they are diatomic, be sure they're listed as diatomic. This is what we do. All elements on the left and nothing but one compound on the right. Okay, so that's an enthalpy of formation. So let's practice doing this. How would we find the heat of a reaction, the change in enthalpy, if we're given enthalpies of formation? Well, our formula for this version of enthalpy is the sum of the heats of formation, or enthalpies of formation, of the products minus the sum of the enthalpies of formation of the reactants. Now notice we're back to our good old products minus reactants, or final minus initial. Bond energy is the only one there's no minus in. It's all addition, and then you need to be sure to know the difference between positive for absorbed for breaking bonds and negative for released for forming bonds. So this is what we're going to do, and you're going to use the numbers provided for you in your notes, and if I didn't have those in the notes, you would go to the right appendix in the back of your textbook, and you would just look up the heats of formation from your textbook. Now, what are my products? My products, I have 5 moles of B2O3. Okay, so what is the heat of formation of B2O3? We are shown right there in our chart, negative 1,272.77. And I'm going to be sure to bring that negative with me. And that's kilojoules per mole. Now notice I multiplied by 5 because there's a 5 there. Okay, the coefficients are in place still. I'm going to add that to 9 moles worth of water. And water has an enthalpy of formation of negative 241.82 kilojoules per mole. Okay, and I got that 9 because of that 9 there. Those better match. And I'm going to subtract the sum of my reactants. Well, my first reactant, I have 2 moles of B5H9. And 2 moles of B5H9 is 2 times a positive 73.2 kilojoules per mole. And I'm going to add to that 12 moles of oxygen, and oxygen is 0. So let's talk about that real fast. Do I need to show it if it's 0? Not technically, but I would strongly recommend you do that just to be certain that you can go through and say, check, got that one, check, got that one, check, that, got that one, check, got that one. Without that 0 to hold your place, you may not notice if you forgot one or didn't forget one. So I recommend it for that reason. And I also recommend it because there are times they actually want to know if you knew that the oxygen would be considered 0. Okay, so let's talk about that. Why is it 0? Well, let's make O2. What are the constituent atoms of O2? Well, you would say oxygen atoms. Well, no, because we're at standard conditions, and at standard conditions there is no oxygen atoms, there is oxygen diatomic. So O2, forming O2 should be a change of how much? Yeah, no change. 0 change. That's why it's 0 kilojoules per mole. So do not be surprised when you have zeros. Expect that if it's an element in their natural state at STP, standard temperature pressure. Okay? So most definitely we could have zeros here. All right. So now we just very carefully plug it into a calculator. Be absolutely certain you either use lots of parentheses or you distribute that negative. I mean, in this example, it's not that big a deal, but if there's a number here, I don't want to subtract both. And when we add that all up, we get a negative 8,686 kilojoules. All right, so let's talk about this real fast. First off, what do we notice? We notice it's a big number, and that just might be the way it is. We also notice it's a big negative number. What does negative tell us? Well, as you were asked in the notes, is it endothermic or exothermic? I hope by now you've figured out that that means it is exothermic. The negative, sorry, there was an IC there. The negative tells you it's exothermic. If it was a positive, it'd tell you it was endothermic. As long as you carefully distribute that negative and do products minus reactants, final minus initial, the sign will pop out of your calculator and you will know whether it's endothermic or exothermic. The downside is if you don't type it into your calculator correctly, then it can't help you out any. So it's also good if you know the equation, if you know like I'm burning something that should be exothermic, be sure you get a negative number. If you know that something is absorbing energy to react, then like the electrolysis of water, you know you have to plug it into the wall to make that happen, then be sure it shows a positive. All right, so that's what we're going to be working on, and we're actually just going to stop here and do some practice with it because this is also something they most definitely and very likely would ask on the AP exam. So let's be certain you have enough practice that this is an easy way to get some points on the exam. Good luck.